Hello, the purpose of this video is to show how to deal with missing entries using SPSS software. And for this demo, I will be using this simple SPSS file where we have 4 variables and sample size equal to 10. Now, before I start, I would like to mention one advantage of dealing with missing entries, and that is to enhance normality of continuous variable. We know that when we intend to run regression, then the continuous variable should be normally distributed. So one way to test normality is analyze descriptive statistics, explore. Then we take, let's say, t-test, this one continuous variable, and then click OK. Then there are a number of tests for normality, and I would like to cite here the box plot. Now, if the variable considered is normally distributed, then normally this median should be appearing in the middle of this box plot. But here we see that it is far below the middle position. So this poses some doubt whether the variable is normally distributed or not. Anyway, when we deal with the missing entries, then we can see that the normality has been improved. Now, in this file, we have 4 variables. Out of these 4 variables, 2 variables are categorical and 2 variables are scale. That means the ratio is scale. And here there are some missing entries, as you see here, here, and here. Now, for categorical variable, usually we go for frequency distribution. Descriptive statistics, frequency, we take nationality here and then click OK. Then we see the percentage of respondents. For example, here 5 Malaysian respondents, 4 international respondents, and missing entries 1. And these are the percentage, 50%, 40%, and so on. Now, there is another column here, valid percent. Valid percent is where the missing entry is not counted in the calculation of calculating the percentage. So that's the valid percentage. All right. So now what we do, we see that there is one missing entry here. And if we go to variable view, we find for nationality, one is used for Malaysian and 2 is used for international. So 1 and 2 have been used. So here what we can do, we can put any value other than 1 and 2. So this should be out of range. Usually we use 99. So 99 actually you are using, and this should be denoting the missing entry. But we also need to declare 99 as a missing entry. If we don't declare, and if we go to analyze again, then missing entries, and then we calculate the percentage, then this 99 is considered as a valid entry. It's not a missing entry. So to overcome this, we must declare that 99 is actually missing entry. So how to deal with, how to declare that? So under missing, then this is none, then we click here, then we click discrete missing value, then we write 99, and then we click OK. And after that, if we go to analyze descriptive statistics, frequency, and then we click OK, then it is counted as a missing entry. And this table will be same as this table. Okay, so this is one thing. I have just shown how to deal with missing entry for categorical variable. What about continuous variable? It is the same process. For example, for regression, we have used under values, we have used 1, 2, 3, 4, 5 to denote various values of various categories in the like-at scale. So 1, 2, 3, 4, 5 have been used. So what we can do, we can write here a very was irrelevant to 1, 2, 3, 4, 5. So this we can write -1. -1 in our case should be denoting the missing entry. But before that, I would like to show the for continuous variable. Usually we compute descriptive statistics like mean, standard deviation. So what we do, we can take regression, then we click OK. Then we see the mean is 3.22, whereas minimum maximums are 1 and 5 respectively. There is also standard deviation. So please note that here the mean is 3.22. So now we write -1, as I was mentioning. -1 is considered as missing entry, but we must need to declare. If we don't declare, and if we calculate again the mean standard deviation, then you see what happens. Then the mean has been decreased from 3.2 to 2.8. Why? Because that -1 has been counted as a genuine value given by the respondent. So that has been counted to calculate the mean, and that's why it's a -1. So the mean has been pulling down. So what we have to do, we must declare that -1 is a missing entry. So the same process like before. So this is -1, click OK. And then we go to analyze, descriptive statistics, descriptive, and then we click OK. Then you see that this mean value 3.22 has been back. It's the same as this value. All right. So this is the way to deal with missing value. But one question here, that I have put all these manually. Let's say our sample size is 400. So we can guess that out of 400, there could be many missing entries. So is it the case that we need to write this -1 or 99 manually in all the places? No, that is not the process. That is, software can put these values 99 or -1 automatically. So I will show here for t-test how the values -1 comes automatically. So what we need to do, we need to click transform. We need to click transform, then record into same variable. Record into same variables, we take t-test, and then we need to go to old and new values, then click system missing, then -1. And then we must click add, and then click continue, click OK. And if we go to the variable view, sorry, the data view, then you will find that -1 appears. So if there may be 10, 20, whatever the missing entry, so this come automatically. So this is one part of dealing with missing entries. Another part is that some statistician suggests that the missing entries can be replaced by series mean. What is actually series mean? You see here, for under regression, there are 9 values have been entered, and only one is missing entry. So software calculates the mean value from the 9 values provided by the respondent. So that's the mean, and this value will be replaced by that particular mean. So how we can do that? But before that, I also need to mention here that -1 has been declared as missing entry. Same thing we need to declare. When the software provides -1 automatically, then we must come back, and then we declare -1 as the missing entry. Okay, so I was just telling that some statisticians suggested that we can replace the missing entries by series mean, but provided that the number of missing entries is below 5%. If it's more than 5%, then it is not advisable. So what is the process? The process is transform, replace missing values, then we bring, let's say, regression here, and then series mean. There are many options. So series means by default, so we keep this option. Then click OK. Then we click OK. And then we see that there is one new variable has been generated by the software, and the missing entry is -1 has been replaced by 3.22. Remember that the mean was 3.22. So this missing entry has been replaced by 3.22. Same thing we can do for another variable t-test. So same process, transform, replace missing values. Then we bring t-test here this time, series mean appears here, and then click OK. Then we see that another variable has been created, t-test_1, and the missing entry has been replaced by the series mean. In this case, the series mean is 2. Now, before we calculated the we tested the normality, and we found that this is the box plot, and it is not that, it does not show that the variable is normally distributed as far as the box plot is concerned. Now, in this case, when we replace the missing entries by the series mean, we go for another round of testing. Analyze, descriptive statistics, explore. Then we take t-test1 here, and then we can also do box normality plots, then click OK. Now we go and check the box plot. Now you see that it is quite close to normal distribution. So it has happened when we have we have replaced the missing values by the series mean. So this is one advantage of dealing with missing entries. So I hope that this video is useful, and we can come back for another video. Thank you very much for watching.